Hello, scientists. Charlie here. I'm trying to work out a model to represent eclipse. And so in the background, you can see I have a beach ball globe and I have a smaller styrofoam sphere that's 1/4 the size of this. 4 of these stacked on top of each other would come up about that high. And so this would be the moon and this would be the earth. And then I have some other models. There's an earth and a tinier moon and so forth. But what happens during an eclipse? I mean, the sun is so big, how can it get eclipsed? Well, let's make this circle the sun. And you can see that if I do this, this yellow circle appears larger than the beach ball balloon earth. And yet, if I put them next to each other, the earth is so much bigger than the yellow circle. So let's pretend that this is the sun and that you are the earth and that this represents the moon. Now, if I put them together, you can see that the moon is so much smaller than the yellow sun. And in fact, this is totally out of scale. The sun is enormous, but I'm just going to use this to represent a large sun and a much, much smaller moon. And so if I bring the sun back far away and I bring the moon close up, pretty soon the moon exactly blocks out the sun. So even though the moon is much smaller than the sun, it can totally block it out. We call this a total solar eclipse. Now, sometimes we get an eclipse where the moon happens to be a little bit further away from the earth, and we get an annular eclipse, which is where the whole moon fits inside the sun. So it'd be like a dark spot with a ring around it. That's an annular eclipse. And a total eclipse, the moon is closer to the earth, and therefore it looks bigger, and it blocks out the sun entirely. So how far something is away, or how close it is, determines the relative size or the apparent size that we see. So even though these two things are very different sizes, if I move the sun back and the moon up a little bit, they can be almost the same size.